Hello viewers, in this video we are going to discuss finding equivalent resistance of balanced Wheatstone bridge. Okay, first let us understand about Wheatstone bridge. These are the different forms of Wheatstone bridge. First we'll start with this diagram. Here Wheatstone bridge consists of 4 resistors connected on the arms of a quadrilateral R1, R2, R3, R4. 4 resistors are connected on the 4 arms of a quadrilateral whose corners are A, C, B, D. Okay. One more resistor or a galvanometer, any other device is connected across 2 corners. Okay. Here between C and D, 5th resistor is connected. This is the general form of a Wheatstone bridge. Now we want to find the equivalent resistance between A and B. These 2 points. Okay. See, if the resistance ratio R1 by R2 is equal to R3 by R4, if a ratio of resistance on AC arm to BC arm is equal to AD arm to DB arm, then the potentials at point C and D, potentials on the diagonally opposite sides C and D are equal. Okay, means potential at C is equal to potential at D. If these 2 potentials are equal, potential between point C and D are equal, then VC minus VD is equal to 0. Means there is no potential difference between C and D points. If there is no potential difference between C and D, then if you allow the current, then no current flows through C to D or D to C. Means this resistor do not conduct the current. In that case, the resistor can be removed. You can remove the resistance. If you remove the resistance, then circuit appears like this. Here this is R1. Okay. And this is R2. This one is R3 resistance. And this is R4. See, bridge is balanced. When the bridge is said to be balanced, if resistance ratio R1 by R2 is equal to R3 by R4, then potentials at point C and D are equal. That's why no current flows through the resistor R5. In that situation, this circuit or bridge is said to be balanced. In the balanced situation, the current is not flowing through the resistor R5. That's why you can remove the resistance R5. Without R5, then the circuit appears like this. In this case, here R1, R2s are connected in series. These 2 are in series combination. Here R3, R4s are also in the series. Between A and B, so you can find easily the effective resistance or equivalent resistance. So what is the equivalent resistance of R1 and R2? R1 and R2 equivalent resistor is R1 plus R2. Here the equivalent resistance of R3 and R4 is R3 plus R4. See, R1 plus R2 is the equivalent resistance of these 2 resistors. R3 and R4 is the equivalent resistance of these 2 resistors. They are in parallel. Means R1 plus R2 is in parallel with the R3 plus R4. That's why the equivalent resistance between A and B, you can write it as the parallel combination. What is the formula, sir? If 2 resistors are in parallel combination, then the equivalent resistance is RAB is equal to product of 2 resistors by sum of the individual resistance. Okay, in this way you can determine the equivalent resistance between 2 points when bridge is balanced. So this is the condition of balanced Wheatstone bridge. Okay, now Wheatstone bridge have different forms. They can give Wheatstone bridge in this form. This is also one of the form of Wheatstone bridge. If you observe it, between A and B again 5 resistors are connected. Between A and B, if you travel in this path, here R1 and R2s are connected. If you travel in this path, R3, R4s are connected like this series. Here also R3 and R4s are connected in series. And R5 is connected between two joints. Here these 2 points behave like a C and D. Okay. Again, if you check the condition R1 by R3 is equal to R2 by R4, then you can remove it and the next circuit appears in the same way. Okay. These are the different forms of Wheatstone bridge. Okay. To find equivalent resistance, we need to follow the same method. Let us discuss few problems on balanced Wheatstone bridge. Here, on the first example, we have 5 resistors and one more resistor is connected between C and D. Okay. Now, we want to find equivalent resistance between A and B. What we want to find? We want to find RAB. RAB means equivalent resistance between A and B. See, in this circuit, first you need to check whether the circuit is balanced or not. What is the condition? The condition is R1 by R2 means ratio of resistance on the 2 arms is equal to R3 by R4. R3 by R4. This is first resistance R1 and this one is second R2. This is third resistance. All the 4 resistors of equivalent resistance. That's why if you check R1 by R2 is equal to R3 by R4, you will get same answer. 1 is equal to 1. That's why this circuit is in balanced situation. So no current flows between C and D. That's why you can remove this resistor. Okay. When this resistor is removed, then it appears like this. Without the fifth resistance, R and R, these 2 resistors are in series combination. That's why what is the equivalent resistance of these 2? R and R series equivalent resistance is R1 plus R2, which is equal to 2R. I am going to redraw another diagram. This R and R 2 resistors are connected between A and B, between points A and B. Okay. On the lower side here, again R and R 2 resistors are again in the series connection. That's why the equivalent resistance of these 2 is again 2R. 2R and 2Rs are connected between A and AB. That's why they are in parallel combination once you see. So RAB equivalent resistance between A and B is 2R into 2R by 2R plus 2R. So what is the final answer? 4R square by 4R. R square gets cancelled, 4 cancel. So final resultant resistance is R. So between A and B, what is the final answer, sir? R. Now in the second example, once you observe the second example, again we have 5 resistors, 1, 2, 3, 4 and middle one more resistance is there. This is also one of the form of Wheatstone bridge. Okay, here this resistor is considered to be R1. Second resistor is this one, R2 is equal to 2R. Third resistor R3 is 2R and R4 resistance is 4R. In between C and D, these 2 points, we have another resistance whose resistance is R. Now Check the balancing situation. R1 by R2 means R by 2R is equal to R3 by R4. R by 2R you will get 1 by 2. If you divide R3 by R4 also, this is R1 by R2 whose value is 1 by 2, and R3 by R4 is also same because 2R by 4R is equal to how much? 1 by 2. R1 by R2 is equal to R3 by R4. That's why this circuit is also in the balancing condition. That's why this fifth resistance you can remove. After removing that resistance in the circuit appears in this way. Okay. Here between A and B, these two resistors R1 and R2s are in series. R3 and R4s are also in the series combination. Okay. So what is the equivalent resistance of R1 and R2? Equivalent resistance of R1 and R2 is R plus 2R. Two resistors are connected in series now. So equivalent resistance is R plus 2R, which is equal to 3R. This is connected between A and B. 2R and 4R are also in the series combination. That's why equivalent resistance of these two resistors are 6R. 2R plus 4R is equal to 6R. So the final answer RAB is equal to 3R into 6R. R1 into R2 by R1 plus R2 real formula. 3R into 6R by 3R plus 6R, which is equal to 18R square by 9R. So final value is the equivalent resistance of this circuit between A and B is 2R. RR gets cancelled. 18 by 9 is equal to 2. What is the final answer, students? 2R. Last one more circuit here. Third example, one more circuit is there. This is also a Wheatstone bridge. We want to find equivalent resistance between A and B. A and B's are taken here. Okay. Now this is A and B. Many resistors are connected in different ways. This is one complex circuit. Except this one. If you leave this R resistance between A and B, if you leave this one, remaining 5 resistors, these 2 plus 2, 5 resistors form one Wheatstone bridge. So this is R1 and this is R2. R3, R4, or you can take it as R1, R2, R3 and R4. This is the fifth resistance connected on the diagonal corners. So if you check the condition, R1 by R2 is 1 and R3 by R4 is also equal to 1. That's why this section is in the balanced condition. This is similar like a balanced Wheatstone bridge. That's why you can remove this resistance. Without this resistance, the circuit becomes very simple and you can solve easily. R and R, in this branch R and R's are connected in the series. That's why what is the equivalent resistance of these two? R plus R, which is equal to 2R. Again, these two resistors are also connected in series. So what is the equivalent resistance? R plus R is also 2R. And one more resistor directly connected between A and B, which is having R resistance. Now try to draw another diagram between A and B. This diagram must contain R first, and this section's equivalent resistance is 2R, and the last branch equivalent resistance is 2R. All the three resistors 2R, 2R and R are connected in parallel combination across A and B. That's why what is the equivalent resistance in this parallel combination? R1 by RAB. RAB is the equivalent resistance between A and B is equal to 1 by R1 plus 1 by R2 plus 1 by R3. Here this is considered to be R1, this is R2 and R3 for this circuit. Now substitute it and simplify. 1 by RAB is equal to 1 by R1 value 2R plus this is second resistance again 2R 1 by 2R plus 1 by R. So 1 by RAB is equal to, if you add these two, 2 times the 1 by 2R becomes 1 by R plus 1 by R. This is the remaining one. So finally what answer you will get? 2 by R. But this is reciprocal of equivalent resistance. Now that's why reverse it on both sides. RAB 1 by RAB reverse, that's why it becomes RAB is equal to R by 2. So the final answer is R by 2. In this way we can solve balanced Wheatstone bridge related problems.